All right, guys. One thing I want to do is talk about the final. I don't even remember what day the final is, but what I'd like to do is to take it. We only have 2 weeks left, right? This week and next week, and then the following week is finals. I'm going to give you the choice of taking it next Wednesday, which is the last day of class, or the following week during finals. So you can come in and take it that day, or, I mean, you don't even have to tell me which. Don't know why I can't talk. Or you can come in on finals and take it. So it's up to you. So let's go ahead and post an announcement to that effect. Be nice if I knew exactly when the final was. Let's look it up. Okay, so our final is May 16. If we pull up the little calendar, that's a Monday. But if you want to take it the Wednesday of next week, you can do that. You have your choice.
That's April.
Pardon me?
That's April.
Yeah, you're right. All righty, we're going to look at that again. May 16th is our final date. Or you can take it May 9th, week before. It's your choice, totally up to you. Not a vote, just come in one day or the other. But don't miss it. That would not be a good thing. That makes sense? Okay. Just as a show of hands, who thinks they're going to take it next week? Who thinks they're going to take it on finals week? We'll do a review of it on Monday of next week. So that way you have a little bit of time to prepare. Same rules. Open book, open PowerPoints, open notes, open anything you've uploaded. Alrighty then. So we're on Chapter 7, Files. Programming languages have different ways of determining how much data to input. All right, yeah. Every language has a different command, right, for reading in. In many languages, a delimiter, such as a comma, semicolon, or tab character, is stored between data fields. Well, let's play with that. Let's play with that for just a second. Go into idle, and we're going to create a little text file. Rather than, actually, we could even do it in Notepad, but idle has a, a text editor. So we're going to create a little text file. Then we're going to open it in Excel. All right, so do a file new. Then immediately do a save as. Save it into your favorite directory, but give it the extension .txt. Do a save as file type. Make sure you do that to text files, right? Save as type text files. And let's just call it April 30 data.txt. Alrighty. Let's kind of do the same thing we were doing last week. Monday, Tuesday, Wednesday, Thursday, Friday. But let's also have a column for names. So name, column, Monday, Tuesday, Wednesday, Thursday, Friday. And then so our name is going to be Joe Bob, comma, and then he worked 8 hours on Monday, 8 on Tuesday, 8 on Wednesday, none on Thursday, none on Friday. And then Becky Rand worked 1 hour on Monday, 2 on Tuesday, 3 on Wednesday, 4 on Thursday, 5 on Friday. And then lastly, Sam Hill no hours on Monday, no hours on Tuesday, no hours on Wednesday, no hours on Thursday, but came in and worked 5 hours on Friday. Okay, this is what's known as a comma delimited file. Delimited meaning just the symbol that separates all the bits of data is a comma. So save that, and then open up Excel. Just go to your start box, or hit Windows R, either way, and type in Excel. So we're going to open a file on this PC, on My Documents, but we have to go to the right directory, right? Seems like every version of Excel makes it more difficult to just get to the hard drive to open something. Now we don't see our file there yet, but that's because it's looking for Excel files. And we're not opening an Excel file, we're opening a text file. So you're going to click this place where it says All Excel Files. Is there one for text? If there's not one for text, we'll just do All. Did you spot it? I'm not. Right there, right there, right there. Text files. It's like 1, 2, 3, 4, 5, 6 down. All right, and then we can double click on April 30. And it comes up with this little dialog called the Text Import Wizard. So it's delimited. Delimited by characters such as commas or tabs. My data has headers. Well, it does. We have these, things up here. So I'm going to click Next. Our delimiter is a comma, not a tab. So you see what it's doing? It's building, a little set of data like this. Next. And these are our headers, and this is our data. No, this is determining the type. You can pick which type is type, but if you choose general, it does a pretty good job of figuring out whether something is a word or something is a number, so I'm not going to change anything. But if you wanted to, you could probably click on one of these and say, no, this should really be a number, and no, this should really be text. But it's going to figure that out on its own. Finish. And there's our spreadsheet, right? So we can make a file in Python and import it into Excel. I'm not sure how you do the opposite. It's very plausible you can, but I'm not sure how you do the opposite. Everybody who at least is trying to get Excel open and import that file? If not, and you want to. So I hear people typing, but nobody said they hadn't got it done. That confuses me. But anyways, I'm going to go ahead and close this. Just wanted to show you that this is a delimited file. It's actually using a parallel array, right? It's got an array of days, and it's got an array of columns. So what am I going to do next? I'm going to delete the top line, just because I don't want to mess with that in Python. Or I could put a hashtag in front of it and write our program in such a way that it would ignore any line that begins with a hash. That doesn't sound like a bad idea. We're going to write our program so it ignores comments. So that's our text file. Just going to kind of minimize that. Now I'm going to write a Python file that'll read that data. And name. The date is April the 30th. File IO example. Read a comma delimited file. So the first thing we need to do is ask the user for the file name. If we don't know the file name, we can't open it. So I'm just going to do file name is equal to input. File name is equal to input. Open what file? And make sure you save this file in the same directory as your text file. If you put it in a different file, it's going to be much harder to debug. And never save things in it as Python 36-32. Eventually, it's going to come back to bite you. All right. I know I've said that before, but I saw people doing it anyway, so just warning you. April30.txt. You can break you can break Python to the point where it won't even run any of your programs and where idle won't load if you save stuff in there. Okay, so file name, open what file? So file is equal to open our file name, comma, R for read, comma, quote, R for read. So you know that syntax, that for each syntax that we've been using to read in, items from an array? Don't type this, but it'll look like this, right? For I in array, something like that. We're going to do the same thing here. We're going to treat the file like it's an array. For line, meaning line of data, in the file, firstly, let's just print it out. Make sure it's working. Right, because if we can't even read in a single line of data, then we're doomed. Once you're done with the file close. File.close, parentheses in parentheses. Now that ought to be enough to run, whoops. I saved this as a text file. I wonder if I erase my other data. Where's my other file? Alrighty. If you're doing what I'm doing and you're typing in all this code and it's not colorized, it's a problem. It's not saved as a Python file. That was totally my mistake. File, save as, and change it to a Python file. And get rid of that .txt extension. So, do a save as, call it April 30 again. Make sure this save as types as Python. All right, and then go back to your other file and hope that it's still there. Okay, April 30 data. Good. I didn't know erase it because it has a different name. All righty. So, all of a sudden my program is colorized. I've got it saved as the right type. I can run it. Invalid syntax. I think I slipped over to writing Java and shouldn't have put the parentheses there. Okay, open what file? April 30 data.txt. And it did open it. Good deal. But there's a couple things we need to do to it. One is notice that when we printed it out, it also printed these blank lines. The input command automatically removes the /n at the end, the enter key at the end. But reading in from a file doesn't remove that. So we're going to remove that from our data like this. Line.strip, like that. That'll strip out all the trailing spaces and any /n's, any enter keys that are at the end of it. Now I'm going to run it again. All right. Open what file? April 30 data.txt. It didn't strip our file. Alrighty, do we have to do this? Line equals line dot strip. April 30 data.txt. Okay, that's looking a lot better. No blank lines in our data. We could have just ignored the blank lines, right? We could have checked the length of the line, and if it was equal to 0, then blow it off. That would have worked just as well. We might still want to do that. We might want to put an if statement that says if the length of the line has to be greater than 0. Because what if there were blank lines in our data? Let's do that. I'm going to take out the line is equal to line. No, I'm just going to comment it out. And then I'm going to put in if len line is greater than 0, colon, print the line. That should have the same effect without using any fancy Python commands for stripping data, stripping spaces off the end. April 30 data.txt. No, that did not work. Okay, I'm going to go back to the strip. Sorry. Maybe I'll leave them both in there. All right. So line is equal to line.strip, parentheses in parentheses. If len, parentheses, line, in parentheses, greater than 0, colon, print line, and then file.close. April 30 data.txt. Okay, yippee skippy. Now we have some data to play with. We could do something with this data. We could do the same kind of program we did last time that added up all the values, right? We'd have to load this stuff up into arrays. I think I'm going to skip that part, but you get the idea. We could pull in each line of data, and then we could fill up an array with that data. Now the only thing complicating it is our data is of mixed types, right? It's got a name, which is a string, and it's got numbers. And our book has said several times that an array has to all be of the same data type. So when we were messing with this, what we would have to do is to make sure that we ignored the first element of it. Maybe, we could put it in and, print it out, but then ignore it. Something like that. But we're just going to ignore the rest of this at this point. I don't see any reason for us to rewrite the program that we did, on Wednesday, taking into account that all of a sudden we have to ignore the first column somehow. So we'll leave that alone. But honestly, it's not really an array of strings and numbers. If we bring it in, what is it read as? Just like the input statement, that's just a pure string. So it'd be okay to put it in an array. I feel like doing that, and then we're going to stop the example. Okay. So, above where it says print line, or below it, do this. Data is equal to line.split, parentheses, quote, comma. What that means is split that data up by commas, by our delimiter, and then stored in an array called data. Create array. Splitting by commas. And then let's print that out, just to see what it looks like. Print data. Alrighty. April 30 data.txt. And there it runs, and if we look at what it generated, I'm going to have to cover up the code for a minute to show you. See, that's the line of data, that's the string, and then this is what it looked like after it got converted into an array. Now there's still a little bit of a problem in that these are still strings, and if we wanted to add them up or do calculations on them, we would have to convert them to floats or something like that. But you're getting the idea. We have taken a file, we have opened it up, and we have read it line by line into arrays. And arrays are how you really process stuff, right? You know, pretty much if you have something in an array, you can rip through it with a loop, you know, convert it to numbers, add them up, do whatever you need to do. I think I'm going to comment out the print statement here because printing it out as an array, we don't need to see what the original line looked like. We care more about the array. Open what file? April 30 data.txt. Alrighty, so there's our program. Now, apparently when we stripped it, it didn't eliminate the leading space, only the trailing space. I'm not going to mess with that. I bet that's because in my input file, I had a space after the name to make it easier to read. No? Well, I see a space there. Okay. That's okay, right. When we converted it to numbers, it would ignore those spaces anyways. I just wanted to figure out why our array looked a little bit different. So I'm going to remove those spaces from my data if you had any, but you don't have to in yours. Alrighty. So that's an example of doing file input, reading things into an array so that we can split them out. I keep wanting to take it a step further and a step further and a step further, but I don't. I think that's enough to go back to the PowerPoint. Anybody's not opening the file and printing it out. .txt, because that's what you called your file. Alright, file name, yeah, it's a capital F. But if you look in here, probably lowercase f. Just make those match. See, file name, no, 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 no. That's fine. See where it says file name there? This one has to match. Can you see the capital F right there? Fix that. Everything else is good. Well, I mean, there may be another problem. Let's run it. April 30.txt. All right, it didn't print anything. I wonder if we'd save this file. Come back up here and save it. Yeah, if it seems to, if it compiles without error but doesn't print anything, it's probably because you didn't save your text file after you've typed it. All right, go ahead one more time. Yeah, good. How can you tell if your file has been saved or not? It's kind of subtle, but if you look up here next to the file name and there's an asterisk, it has not been saved. So the most common mistakes I saw is if you left off this last line here, print data, it would run, but you wouldn't get any output because we'd taken out the other print statements. Like that. And I got tired of typing in April 30 data.txt, so you could just copy that and then paste it each time it asks for the file name if you're testing it over and over and over. Let's go back, add that again, and off we go. So here's their example of a comma delimited file. Right? You got your name, then you got an address, and you got a number, pay rate. So in memory, when you read this in, from the disk, the first chunk of data, Matthews, the second chunk of data, the address, the third chunk of data, pay rate. Just like what we did. It converted it into an array, although they may just be storing those into variables rather than putting it into an array, but very similar concept. So sequential file. That's when you open a file from the beginning and go all the way to the end, processing a record one at a time. And that's what we've done. You know what? I'm not sure how our program worked. Did it work? Is it putting those asterisks, the line with a, I can't even talk. When I run it, do I see the comment that's in my file? Yeah, I do. I actually wanted to ignore all data that started with a hashtag. I am going to add that. So where it says if the length of the line is greater than 0, we're going to add an AND clause because we want to make sure that it doesn't equal to the pound sign. So if the length of the line is greater than 0 and the first character of the line, line subscript 0, is not equal to shift 3, pound sign, hash. Now when we run it, it doesn't print out that header, which is good news because remember that header had things that weren't numbers, right? It had month, day of the weeks, and you couldn't do math with day of the weeks. Printing it out is fine, but trying to store it in an array and then handling it, not so good. So what is sorting? Sorting is a process of placing records in order by the value in a specific field or fields. Ascending order and descending order. I hate to waste 4 sheets of paper. I wish I was scrap paper here. I would do a sort. I would hand each one of y'all a number. I'm not gonna do that. I'm not gonna waste 4 sheets of paper. All right. So anyways, there are different sorting algorithms, but one of them is just when you go through the array looking for the lowest value, right? I go, are you the lowest? No. Are you the lowest? No. Are you the lowest? No. Are you the lowest? Yes, you are. And then I take you and I put you at the beginning and I swap those two. Then I'm looking for the next lowest. Are you the next lowest? Are you the next lowest? Are you the next lowest? You're the lowest, so put you here and you here. I get arranged by height or age or something. And then I'd say, are you the lowest or you the lowest? Turns out, then swap you two. So that's called a selection sort. When you're running down the list sequentially, finding records and putting them in their correct place. Now that's not the most efficient way of sorting. There are much more complicated sort algorithms that give you better performance. But sorting is fairly important. The concept of it is. Because if you can sort something, then it's easier to find a value. And I've done this before, right? Just like the guessing of the 50 in your guessing game. 50 is between 1 and 100. And then you find out, no, it wasn't right, and I got to go to 25. And 25 is not right, I go to 37, right? You keep zeroing in on like. You can only do that if the data is sorted. So that's the binary search. The binary search is where you jump to the middle. You check to see whether you need to go greater or less than. And you go greater or less than, you jump to the, you eliminate the lower half or the upper half, and then you jump halfway between what's left. Can't do that unless it's sorted. So writing data to a file. When you store data in a computer file, you write to that file. So for example, here's our pseudocode. Output the name, address, and pay rate to employee data. Now every time we've seen the word output before, it was a print statement. But if we're writing to a file, it's the write statement in Python. Not write as in R-I-G-H-T, it's write as in write with a pencil. And then when you're done writing to the file, when you're all done with it, or even when you're done reading, when you're finished with the file, you should close the file. Always close every file you open. If you leave that file open, then the operating system may lock the file, and it may not let it be copied into another directory, something like that. Another program may not be able to open it and read it while your program has it open. However, default input and output devices, the keyboard and the monitor, do not require opening or closing, but we're talking about reading from a disk or reading off the internet or reading from a flash drive, something like that. So what is a backup file? Oh, come on, we know what a backup file is. It's a copy kept in case the values need to be restored to their original state. The backup copy is called the parent file. And then if you're revising it, the newly revised copy is called a child file. So a program that performs file operations. All right, so we declare an input file name, we declare an output file name, and then we create some variables. Remember that, in other languages you have to create all your variables before you can use them. So then we do some housekeeping. What is housekeeping? We come and open the file. And then we open the file that we're going to be writing to. And then we input the name, the address, and the pay rate from the employee data file, and then we return. Okay, great. Were we at the end of the file? No, we're not at the end of the file. Okay, do the detail loop, which calculates the pay rate by the pay rate plus the raise that they got, and then it writes it out to the new file. Then it returns. And it keeps doing that over and over and over. I'm sure that there's a read down here at the next one. Yeah, another read. Where it's saying input, I sure would have preferred to use the word read, right? Because input is typing from the keyboard. So we keep doing the detail loop until we have no more data, and then we finish, which closes the files. Notice that this is one of those examples of a priming read, which my tendency is to try to avoid, to program in another way that doesn't use a priming read, right? But it does something called housekeeping, which opens the file and reads it in originally. That's the priming. And then it decides where you're at the end of the file. Well, if there was no file, though the file was empty, we would fall straight through. But if the file wasn't empty, we would do something with that data, right? We calculate their pay raise and write it out to the other file. And then read in the data again. Then I would check again. Are we at the end of the file? No, we're not. So repeat. There's the code for it. I'm going to skip the code. So control break. A control break is a temporary detour in the logic of the program. A control break program uses a change in a value to initiate special actions or processing. Like what if you were keeping track of sales? Well, let's see what their example is. So here we have our data sorted by state. We're reading in our program, our data line by line, but whenever the state changes, we do something else, a control breaks. We're doing something temporarily different. We're no longer printing out each line of data. Instead, we're going to count how many things we read out. We're going to print that out, and we're going to print out a blank line. Then we're going to go back into our loop, and we keep reading, right? And this is our next thing that we're reading. And as long as we keep reading Alaska, right, it's doing the same thing. But then once that field changes from Alaska to something else, we control break again. It prints out the count. It prints out a blank line. So control break is when you have a sequence of data, but then it changes. So another example of that would be, what if you had a list of a purchase, right? And this is order number, and then an item number. So for order number 1, we purchased item number 100, but on order number 2, we also purchased item 102. And for order number 2. Order number 1 also has item 193. And maybe we even put quantities. They ordered 1 of item 100. They ordered 102 of item 102. That's stupid. They ordered 50 of item 102, and then they ordered 17 192s. Now, somewhere else, there's going to be a database that corresponds item numbers to to data, right? So we might have a database somewhere else, another file that says the item number and then the description, right? And so order number 100 is, a washing machine. Item number 102 is a fridge. And I don't know why they're ordering 50 fridges, but let's just go with it. And then item number 192, right? There could be, thousands of items in this file. 192 is a microwave. And so the first order consists of one washing machine, one fridge, and one microwave. And then that's it. So order number 2, they wanted 2 washing machines. And they wanted 1 microwave, and then that's it. And the third person just wanted a fridge. So there we go. So this is kind of a mini database, right? We've got 2 files. Remember we said that a database is a collection of files. So, and we're tracking it by the order number, the item number, and I need to put a comma, quantity. We're reading our data, we're calculating, we're printing out the order, we're calculating totals and stuff like that. And as long as the order number is the same, great. But as soon as the order number changes, we got to do a control break. The control break, prints out the page of data or writes it to them, sends them an invoice, something like that. And then it comes back in. It starts reading. But now we have a new purchase number, order number. And so then it goes through again. Purchase 2, only had 2 items, And then the order number changed again. So our control break, generated an invoice for these 2 numbers. And then we read another line of data. Great. Order number 3, only had 1 item. And then we've hit the end of the file. End of file also serves as a control break, right? Because, there's nothing more to read. So we print out that invoice. Nothing else in the file, so we're done. So examples of control break reports. All employees listed in order by the department number. And you want a new page started for each department. So you have a file, a list of departments, and a list of employees per department, right? So it says Department 1, Joe. Department 1, Bob. Department 1, Becky. Then the department number changes. Department 2, John. Department 2, Hassan. Department 2, whatever, and then it goes to Department 3. And every time the department, every time the department number changes, you do a control break. You print out that page, and then you go to the next page, ready to print out. So that you can print out the entire department with a new page started for each department. Or all books for sale in a bookstore, listed in order by the category. All the self-help books. All right, now we're done. All the, fiction, science fiction books, all the historical books, like that. And each time the category changes, you do something out. And then all items in order by date of sale. Kind of like the one that I generated, right? Except that was just ordered by purchase number. That's kind of a date of sale, but not really. But we could have, added a date of sale. And then if our data was sorted by date of sale, same idea. With a different ink color for each new month. Well, that's pretty cool. They have a printer with 12 different colors of ink. I'm impressed. So a single level control break. That's a detour based on the value of a single variable. Uses a control break field to hold the previous value. Right? Because when we were reading this in, we had to have somewhere that stored that number so that when that number changed, we knew when to stop. So this is an example of a single level control break here. Each time the order number changes, that's our control break. So in order to handle that, we had to have a temporary variable that holds the last item number. the last order number, so when we read the next line in, we know if it's changed or not. Let's modify our data so that it has a department number. Let's go back to your file if you still have it open, April30data.txt. We're going to add a column. So department number. And so department 1 has Joe Bob, Becky Rand, and Sam Hill. I forgot to put commas. 1 comma Joe Bob. 1 comma, 1 comma Becky Rand, and then 1 comma Sam Hill. Then it changes. I'm not going to do a lot of these right. You know, Donald Trump's working for us. Donald Trump works 10 hours a day every day. 10 comma 10 comma 10 comma 10 comma 10. Also, Bugs Bunny works for us. He never shows up. 0 comma 0 comma 0 comma 0 comma 0. Then we change departments. Darth Vader works for us. Works 1 hour a day. Must be in management. All right, so there we go. Then when we read our data in, we will be keeping track of the department number. And when the department number changes, we want to do something to our output. Maybe print a line of dashes or something like that. So I think we ought to modify our program to actually do that. I almost don't want to make our program too complicated because I just like the fact that it shows you how to read a file. But I want to carry through with our example. Alrighty, so we need a last department variable. Last department is equal to 0. Oh, this is going to be getting to the point where we need to start converting numbers and stuff like that. I don't feel like writing the code that's going to convert strings to numbers and stuff like that, so I am going to leave it as is. But you get the idea. As we read this stuff in, we check to see if this number equals our last department number that we read. And if it does, great. But if it doesn't, it's time to like print a break in our report, you know, or eject a page, or do whatever we want to do when we're done with that department. I guess it wouldn't take that long to do. Let's do it. Let's do it. Okay. So last department equals empty string. 2 quotes. Or 2, double quotes. And then we read our line of data in. If the line length is greater than 0 and the line length is not equal to our hash symbol, then we've got good data and we need to do something with it. So we're going to check to see if the department that we just read is equal to the department that we last read. So department is equal to the... No. You have to do this after we've split the data, right? So department is equal to the first line of data, the first element of data. So above our print data, I just added this statement. Department is equal to data subscript 0, first element of our array. And then if our department is equal to our last underscore department, we're going to print something out. Print department report. Excuse me. If our department is not equal to the last department, make sure you change that to a not equal right there. I wish I hadn't said that. Change to not equal. I'm putting a comment here. Don't put the comment here. Just note that that's where I want to do it. Make sure that says not equal right there. If department not equal last department, then print out department report. Then print out our data and then reset our last department variable, right, so that it'll be the last one we just read. Last department equals department. So that's the other line that we just added right there. So we've added a few lines, right? I just added this line. I'm going to mark it with 3 asterisks, 3 hash symbols. We added this line, and we added this line. That'll help you zero in on the changes that we need to make. Let me test it before I brag too much about it. Open what file? April 30 data.txt. And there we go. You see what it did? When you run it, department report, it prints out everybody for department 1. Department report, it prints out everybody for department 2. Department report, it prints out everything for department 3. And, you know, it would be a little bit more sophisticated, right? We might add up all the, you know, all the hours that they worked or whatever. But that's the idea. That's a control break. This is a control break using a variable, a single variable to hold one of the items. Now guess what? If you have 2 things that change, like a department number and then you know, a location, right? You know, so you have workers at, you know, San Jose, and you have workers, you know, somewhere else, Oklahoma City, and some workers in Tulsa and stuff like that. I'm not going to demonstrate that, but you just have another column in our data file, and you'd have 2 variables, last department and last location. And anytime the department changes, you take note of that. Anytime the location changes, you take note of that and do another control break. Now, do you really see a break statement? No, the term break is conceptual. Here's where our break occurs, conceptual break. If the department does not equal the last department read, then do something special for a while and then come back in and start repeating our actions. So working for everybody. So that last department variable was our so-called control break field that held the previous value. So merging files, that's when you combine 2 or more files while maintaining the sequential order of the records. So you have a file of current employees, you have a file of newly hired employees. You have a file of parts manufactured in North Side, and then another file containing all the parts made at the South Side factory. And you have to merge them. And you want to maintain their order, their part number order. Just tuck that away as something that conceptually that you might need to do, but really I don't want us to memorize the code or the pseudocode for it, or the flow chart. But conditions required for merging the files. Each file has to have the same record layout, and they have to be sorted in the same order. Now, when we're talking about the same record layout and sorted, there's a fair likelihood that if you're doing file I/O, you'll be asking databases for this data rather than opening the file yourself. And then the database server handles opening the file and feeding your data back. And you tell the database what you want your data sorted on. I want my data sorted on employee number. I want my data sorted on the purchase order. I want my data sorted on the purchase date, that kind of stuff. So here's our East Coast file. And here's our West Coast file. And when it merges it, right, Abel, Brown, Chin, Doherty, see it's reading one from each one. All right, I see people not looking at me, which is okay, but you know, I hope you're absorbing it for the exam. Mainline logic is similar to other file processing programs except for handling two files when you're merging the files. So the master and transaction file processing. Some related files have a master-transaction relationship. There's a master file, which holds complete and relatively permanent data, a transaction file, which contains temporary data, to be used to update the master file. And then you update the master file. Right, so what if you have a master file of inventory, and then you have a transaction file of the purchases? Well, your purchases are eventually going to affect your inventory, right? They're going to lower the inventory by the number of the items purchased. So you have the two files, the master file. That's a permanent file. By permanent, I mean, you're going to be constantly maintaining it day after day. And then the transaction file. All the purchase orders get put in there for that day, and then they get applied to the inventory. Now, what happens if they ordered more inventory than you had? Well, my example didn't cover that idea. So you have a master file, a transaction file. You update the master file based on the contents of the transaction file. Examples. A library maintains a master file of all patrons and a transaction file with information about each book or other items checked out. A college may, that way you can update at the end of the day. This person had this many books checked out and which books they had checked out. This person had these books checked out. A college maintains a master file of all students and a transaction file for each course registration, right? You go into an enroll, it generates a transaction file of everything that you enroll in, and then it goes and it updates the master file with that information. Why not do it as you're changing it? Because, you might cancel, right? You fill out 20 things and then you decide, no, I'm going to cancel. That's not the way our enrollment system works, but it could be, right? You add all your files, like an Amazon purchase system, right? You fill in all the items that you want to buy, and then you click submit, right? And until you actually click the purchase button, it's not going to go out and modify the master file. So the master and transaction file processing, updating approaches. You're going to change the information in the master file. You're going to copy the master file and change a new version. Each time you copy and create a new version, you're creating more file space and stuff like that. But then if something goes wrong in the middle of the transaction, it's okay, right? Because you can always roll back to your original file. So you begin with both files sorted in the same order on the same field, right? This person enrolled in this file. In this class, this person enrolled in this class, this person enrolled in this class. All right, for those of y'all looking at your phones other than me, sorry to be a jerk about it, but I really hope you're paying attention. These questions could show up on the exam. You shouldn't be watching me just because I'm typing, right? Unless you're sure you already know all this thing and you're just gonna, look at the PowerPoints later or something. All right, we're going to hit the end of this PowerPoint pretty soon, and this is the last chapter. But I have something else I want to do on this topic, so we'll be able to do that on Wednesday. Random access files. We've been talking about sequential files. Sequential files are when you open it from the top and you go all the way to the bottom. What's a random access file? A random access file is when it'll jump around, figuring out what it needs to update. So batch processing involves performing the same tasks with many records, one after the other, which uses sequential files. Real-time applications require the record be accessed immediately while the client is waiting, right? If you go talk to Steve Johnson, the advisor, he's going to pull up your records. He doesn't want to read in, or his program doesn't want to read in, 20,000 student records. It's just supposed to go and get the right record right then, for you, so that you can, you can do some information with it. Interactive program is a program in which the user makes direct requests. So random access records can be physically located in any order, and it's up to the software, the database program, to return you the right record based on the record that you asked for. So instant access files, files in which records must be accessed immediately, also known as direct access files. So you can access a target record sequentially, or you can access a target record randomly. Now, in order to access a target randomly, it has to have some way of knowing which record is which, right? So that's when an index file is used. An index file is a separate file that is used to access randomly into this file. And this isn't a database course, so I am going over these slides kind of quickly. So summary, a computer file, a collection of data stored on a non-volatile device. Volatile means if you turn it off, it loses its memory. Non-volatile means it stays. Data items are stored in the hierarchy. We've talked about the hierarchy, right? Characters. Fields are made out of characters. A record is made out of fields. A file is made out of records. And then a database is made out of multiple records. So we created a file. We didn't actually really create a database. But this is a file. I guess a database can consist of one file, right? One or more files. Each one of these is a record. All the fields are separated by commas, and each field consists of characters. When we want to actually do some data on it, we're going to be converting our numbers, our characters, into numeric values. So what is a control break program? It reads a sorted sequential file and performs special processing based on a change in one or more fields. Just like every time the department number changes, we do something different. Merging files combine two or more files, maintaining the same sequential order. The master file is something that holds the permanent data, and then you have a transaction file which updates the master file. When you take a database course, some of these concepts are actually going to apply, but you're not going to be writing the code that creates the database, right? That updates the database. That's kind of a specialized topic. But you'll learn how to create indexes for it, with commands. I do recommend taking a database course. So the master file, whoops, I already read that, holds relatively permanent data updated by transaction files, real-time applications. The real-time application is when the user is sitting there and they want to change their record, right? You want to pull up your old Amazon purchase. You want to log in, get your student information, and enroll in new classes. Requires random access files, where records can be located in any order. And then an index file is used to sort and get into that. So instant access files and direct access files are files in which the records must be accessed immediately. I think I'm going to have to reread the chapter because I don't even know what that means. If you get asked a question about instant access files and direct access files, just load up your textbook and do a search and find it. I'm not going to ask a question on my exam about them. All right, gang, we're done for today. On Wednesday, we're going to create a database, but it's going to be a database of turtle commands that control the turtle moving around the screen. So that if you wanted to draw something with the turtle, you wouldn't code the turtle program. Instead, you would give it a database of commands, and it would draw it for you. And that's much more realistic, right? If you have a drawing program, if you have Microsoft Paint or something like that, you wouldn't want to have to change the program every time you wanted to make a new drawing, right? Instead, you'd just give it a data file so that it could open the file and draw it for you. All right, let's make a Dropbox. We already have a homework assignment, so I'm not going to dump a new one on you. Right, parallel array, months and temperatures. Yep. All right, so this is going to be QRST. This is going to be T. All right, there's the Dropbox, Dropbox T. Go ahead and upload both your TXT file and your data file. And if we had a few more minutes, what we would have done is to make our program write out a new file. based on the file that we read in. But you've already got the concepts down. All right, any questions? Anybody need to stay after and talk about homework? That's totally cool.